In this film, we're hoping to help householders to understand what they can do to their buildings to really make them more comfortable, to save on their fuel bills, and also to help with their carbon dioxide emissions to the environment, and therefore help with climate change. The key in the Colne Valley is that we have a tremendous number of buildings that are hard to treat, and those are hard to improve. We are specialists in very low energy building. And our particular specialism is in passive house standard building. Now, passive house is a building methodology that's spreading throughout the world. It originated in Germany, and it really gives people the best opportunity to build low energy buildings that really work well. And we built one of the first in the UK, so we really do know what we're doing. You can apply the passive house methodology even if you don't achieve the standard to refurbishment of buildings, and that's really what we've done. We've looked at some of the hard to treat buildings in the Colne Valley, and we've used the passive house methodology to assess what we can do to those buildings and to assess the energy use when we've done it. The key principle in improving the energy efficiency of our buildings is to think about the fabric first. Now, the fabric of the building means the walls and the roof and the floors, so we need to ensure that we've improved those as much as possible. And once we've improved those, the building will carry on working efficiently for the rest of its life. So we insulate the walls, we deal with the airtightness, we deal with the thermal bridging, and then we've got a robust solution to energy efficiency. We can then think about possibly adding on some renewables as well. But if we do it the other way around, we've got a leaky coal building that we're putting this advanced technology onto, and really it's not the right way around. We need to think about the fabric first. It's a key principle.
I bought this property specially 2.5 years ago because as I'm getting older, I wanted to live somewhere that was going to be very energy efficient, so that I wouldn't have to pay massive bills as I become a pensioner. So I've downsized. I used to have a bigger house, and I've bought this very small terraced house with a view to insulating it fully, so that it would become a really lovely, warm, cosy and hopefully cheap house to run.
To make a building energy efficient, there are 4 key principles really, and everybody's aware that we need insulation. It kind of feels obvious, but insulation won't work unless we adhere to all of the principles. So, as well as insulation, it's also important that we make the building very airtight, because air movement through insulation and through the building means it reduces the effectiveness of the insulation. We need to ensure that the insulation is continuous, that there aren't gaps in the insulation due to the building structure. For instance, things going through the walls that go through the insulation, or where one part of the building meets another, where a wall meets a floor, for instance. So that's very important. And finally, when we've done all of that, we need to think about the ventilation, because normally our leaky cold houses do have good ventilation. They've got the wind is blowing through the building. Once we start sealing them up, we have to think about a ventilation strategy, so we still have good air quality and we clear the humidity out of the building. If we don't consider all 4 together, then we're likely to have unintended consequences. It is really important that we do these things at the right time in the building's life. If you take your kitchen out, then it's clearly a good time then to insulate the walls behind and to make the floor airtight before you put a new kitchen back in. If you take the kitchen out especially to do that, it's much more expensive, and that's the same anywhere through the building. So you can do these things in stages as you improve your home anyway, and then the cost is much less than if you do it specially.
We started off not specifically to make it very energy efficient. It was a fairly big job, and we pretty much stripped it back to the bare timbers. To insulate underneath the ground floor and up in the loft, we use a mineral fibre wool, which is very inexpensive. Then on the external walls, we used insulated plasterboard, which is then in effect glued to the existing walls, and that accordingly can reduce your heat loss from those walls by sort of half. And it does make a big difference when you actually touch the wall, the external walls and the internal walls. It's a very even temperature. In terms of airtightness, we used the airtightness membranes and tapes. For example, underneath here you've got a membrane which goes all the way underneath, and then it's taped all the way around the edges, and then you've got the mineral wool on top of that.
In my house, I've tried to take a strategic view of the whole house. The ground floor and the first floor were all insulated, all the external walls are insulated, and we had dealt with most of the airtightness issues there. What we're left with is the roof and the attic space, and the attic space is still incredibly drafty. We'll then join that up with the other work we've done going down through the house. So eventually we will have worked around the house and gone around the whole envelope, but over a period of time.
As we make a building more airtight, obviously we're stopping the drafts, and that causes problems in its own right, or can do, if we're not getting rid of the stale air and also water vapour, which we're creating through showers and baths and cooking. Obviously opening windows is the first thing one can think of. Extractor fans in the kitchen, which is what we're normally putting in a new kitchen nowadays, and then again with the trickle vents over the windows in the dry rooms. The next level of ventilation strategy is MEV, mechanical extract ventilation, where you have a central fan which then has ducting to your wet rooms, kitchen, bathroom, utility room, and that can actually work at a very low level. We call it trickle vent. Then of course we've got what's called MVHR, mechanical vent heat recovery. That is the ultimate, if you like. We have to have very airtight buildings to make this economic, but it's a very controlled strategy where you have exactly the right fresh air in every part of your building, and the outwardly extract air is taken through a heat exchanger.
We've looked at the two houses using a tool called Passive House Planning Package, which is a software where we plug in all of the data from the houses, and then we can look at the effect of different measures on the building. So we've started with the house unimproved to work out the likely energy use of the building, and then we've gone on to add different measures. So we've added insulation, we've looked at the other details, so the thermal bridging and the ventilation strategies and the airtightness, and we've done different levels of that to see what the effects are.
Today we've been testing an existing house to see if it has any unintentional leakage. So if you think, a house is not a balloon, so any cold air that's coming in is pushing out the hot air that you paid for. So what we're trying to do is identify the places where the cold air is coming in and pushing out that hot air, and if we can eliminate some of those holes, then they'll save energy.
The Victorian terrace, it's a very typical property in the Colne Valley, probably built in the 1890s, a mid-terrace. This is a typical construction, which is stone outer walls and a brick inner wall. These houses are very drafty, particularly where you've got suspended timber ground floors. Option A, the low cost option, would be topping up your loft insulation to something like 300, which is recommended now. Simple draft proofing measures, looking at how your windows and doors close, putting in proprietary tapes in those situations, maybe even looking at how drafty it is underneath your skirting, putting a bit of filler or silicone in those situations. For option B, which is good practice, we're looking at cladding the inside of the external walls with a wall boarding, polyurethane in this case. We're looking at bringing that polyurethane into the window reveals. We're looking at taking some floorboards back at the edge of the external walls and rendering the bare brickwork there just to cut down on the drafts and taking our insulation down in that area. We have to have a ventilation strategy because we've improved the air tightness. Now, whether that's simply good extract fans from the bathroom and the kitchen and trickle vents over windows, or whether we need something a bit more complicated. Option C, the most efficient option. We're looking at the same strategies with insulation, replacing the windows and installing triple glaze. In getting the air tightness right down. We're going to be using tapes and membranes around floor joists, tapes around windows into the wall. And in doing that, we're able to use the MVHR system, mechanical vent heat recovery. The semi-detached house we're looking at was built in the 1940s by the local authority, and it's very typical of the mid-20th century housing in the Colne Valley. These are brick cavity and they have solid floors, and basically it has a lot bigger external area. So typically we're losing a lot through the walls, far more than the Victorian terrace, even though it's a much later house. Option A is topping up the roof void to 300 millimetres, usually of fiberglass. We've got to pay particular attention to the loft hatch, which is usually very drafty. We've got to think about the walls, and in this case with cavity wall insulation, we've got opportunities of improving the performance dramatically. And of course we'll look at the drafts around windows and doors, and if we can underneath skirtings and so forth on the first floor. For option B, we're looking at internally cladding the external walls as well as cavity wall insulation. So this will be polyurethane back plasterboards taken into the reveals of the windows, making sure the junction between roof and wall is dealt with by putting an angled piece of insulation so that we get continuity of insulation from our wall into our loft space. With option C, we're taking the passive house methodology and trying to get to the levels called Enefit. This is about 10% heating demand of the existing house. The way we do this is that we're going to wrap it externally. This means that we can get over all the cold bridges of junctions with floors meeting walls and roofs meeting walls and so forth. And this is done by putting on 250 millimeters of polystyrene externally, and that would then have either renders or even brick slips put on like tiles to mimic what's there already. It would probably mean stripping the roof so that we could get at all the junctions for airtightness measures and upping the insulation to 450 millimeters. It would be dealing with the solid ground floor by putting on vacuum panels, which you can get a very good U values or thermal values by quite a small depth. We've got to change all the glazing to triple glazing. We can use a very efficient heat recovery ventilation system.
I lived in Dalton 13 years. I had central heating, gas fires in all rooms. I acclimatised to it, but everybody used to complain how cold it was. And I didn't realise how cold the house was until I moved here. I used to pay direct debit monthly at my other house, and which was £90 a month, and my electric was £50 a month. When I got my first bill here, for my 3-month bill was £84 something pence for my gas bill and £24 for 3 months for my electric. I wouldn't swap it for the world. Wouldn't. Absolutely love it.
There are lots of resources available. There are resources on the brochure that go with this film, and there are quite a lot of resources on our website as well at www.greenbuildingstore.co.uk. And if you want to know more, you can go to the Warmer Homes website, which is www.warmerhomes.org.uk.